In the last class, we were discussing an introduction to the C programming, then a basic C program, its structure, main function, or how to use printf. All this we just covered as an introduction to this programming. So now we will learn in detail about the constants, variables, and data types. This is very much needed so that we can start coding. Okay. So C tokens, in the last class also we discussed tokens, they are the smallest individual units in C language. It's the smallest individual units. They are called C tokens. They are broadly classified as keywords, identifiers, constants, strings, special symbols, and operators. We discussed in detail about the difference between keywords and identifiers. Keywords have a specific meaning. Float means it is a data type representing numbers with decimal points, or while it's another keyword. Printf, scanf, all these are keywords. They have a specific meaning in C. Identifiers means they are the random names we give for variables or functions, and keywords should not be identifiers. We should name the identifiers in such that it consists of characters, and it should start with underscore. It can contain digit also. All these we covered in the last class. Then constant means they have a constant value. Then a set of characters is called a string. It is enclosed in double quotes. Okay, and there are special symbols. All the brackets include special symbols. Then operators are there, which are plus, minus, star, slash. These are the main operators that we use. So these are the general classification about C tokens. Now we will learn about constants. Constant refers to the fixed values that do not change their values do not change during the execution of a program. Broadly classified as numeric constants and character constants. Again, numeric constants are divided as integer constants and real constant. Real means floating point values, that is those with a decimal part also. Okay, integer means it's a whole number. Then character constant, it is either single character constant or it can be string. String means it is a set of characters, single character or multiple character, that is string constants. String constants is normally enclosed in double quotes. Single character, it is enclosed in single quotes. Okay. So constants classified as numeric and character constants. Numeric further classified as integer and real constants. Real constant, the other name is floating point. Then character constant classified as single character constants and string constants. Then in integer constant, it refers to a sequence of digit, and there are three types of integers. Decimal integers means that we normally use. It includes digits 0 to 9. And then octal means it is 0 to 7 with the base 8. You must have covered it in school level, the different number systems. Base is 8. That means total 8 digits, which include 0 to 7. Then hexadecimal, the base is 16. One is 0 to 9 and then A, capital A to capital F. So base is 16. So these are the three major types of integers. Normally we use decimal integers, and it includes the digits 0 through 9, and it's signed, so it can have plus or minus sign. Then real or floating constants, that is in some quantities like distance or temperature in Celsius or Fahrenheit, price of a particular commodity. It need not be a pure integer, whereas roll number, etc., there are a number of books or number of pen. Such numbers can be integer itself. So based on the requirement or based on the type of a particular quantity we need to address, it varies. Some are integers, but some need not be integers. They have a decimal value also. So in such cases we can't define it as an integer, but we need another method, so that is real or floating constants. So if you want to represent a quantity with value 17.548, we need floating constants, real or floating point constants. Then character constant, it is a single character constant enclosed in single quotes. Example, 5, if we write 5 simply, that is an integer constant, but whatever you enclose in single quotes, it will be treated as a character constant. Even if semicolon when included within single quotes, it is a character constant. Space within single quotes, all these are examples for character constants. Then you need to know what ASCII values. ASCII stands for American Standard Code for Information Interchange. Just like number system, this is character system. It's a character encoding scheme. So here all the character and special character is represented in 7 bits. It's a character encoding scheme. So commonly used one is ASCII code, and each character and each symbol has a corresponding value, and that is in number range with 7 bits. So for example, ASCII value of A is 65. Okay, you can see the various ASCII values here. For each and every special character, digits, small letter A to Z, capital letter A to Z, all these are having a corresponding ASCII value which is given here. Okay, so let's check an example. The value, ASCII value for capital A is 65. Okay, so you know that. And A, when enclosed in single quotes, it's a character constant. So you can check this example. We have covered printf, how it works in the last class itself. So you can check this. Printf percentage d means it is expecting an integer value to be printed. So single quotes A means when printf percentage d is given, the corresponding integer value of A can only be printed. So ASCII value of A is 97. So this command would print the number 97. Whereas when you give percentage C, it represents character. In such case, when you give 97, it has to print a character. So character corresponding to the ASCII value 97 is printed. So small letter A 97 comes here. And you should remember one more thing, ASCII value for capital A and small letter A are different. You need not learn this table and all, but just understand how the ASCII code is given. It's from 65 to 90 is capital letter A to Z, then 97 to 122 you have small letter A to Z, then special characters are there. Okay. Next is string constants. In character constant, they are enclosed in single quotes. In string constant, string means it is a sequence of character and they are enclosed in double quotes. Characters can be letters, numbers, special characters, and even blank space. All these are examples for string constant. You can check the last example, X. It's a single character, still it is not a single character constant. Why? It's not a character constant because it is enclosed in double quotes. That is the difference. This is a string constant because it is enclosed in double quotes. But if we write it in single quotes, it will be a character constant. Okay, character constant is not equivalent to single character string constant. Okay, this is an important point you should understand. Okay, then character constant has an ASCII value. That is clear from the last example. ASCII value, if you give the ASCII value and print percentage C, the corresponding character will get printed. But in case of string, it is taken as such. So ASCII value will not be taken as equivalent to a string constant. Okay, so string constant does not have an equivalent integer value. Okay. And character strings are often used in programs to build meaningful programs. Like in a program, if we need to save the name of various subjects like physics, chemistry, like that, it's a set of characters. So in such cases, we use string constants enclosed in double quotes. So we learned the basic different types of C tokens and different types of constants. Now we can check the different data types. C language supports 3 major classes of data types. One is primary or fundamental data type, that is already defined or predefined data types are primary data types in C or fundamental data types in C. Next type is derived data types. Next is user defined data types. So the entire data types are classified under these three headings: primary or fundamental data types, derived data types, and user defined data types. In primary data types, again, there are 5 fundamental data types. One is integer, int. Int is the keyword. Then character, char is the keyword. Floating point, that is real constants, real values. Floating point, keyword is float. Then double precision floating point or keyword is double. And fifth is void. Void means nothing or no value. There are instances when we need to specify that there is no value. So for that we use the keyword void. And the explanation will not be clear for a beginner. That will be more clear when we discuss function. Function has we have a provision to return the value. So if no value has to be returned, we can use void. Another thing is there are some arguments that has to be passed for a function to work or for a function to be called. So in that case, if there are no arguments, then also to represent that there are no arguments, you can use void. So void simply means nothing or no value. So these are the 5 fundamental data types: integer, character, floating point, double precision floating point or double. In short, it is called double itself, and void. Then now let's, already integer, character, and float also So first thing we need to study is the difference between float and double. Okay, floating point is stored in 32 bits with the 6 digits of precision. 6 digits means after the decimal point, float saves 6 digits after the decimal point normally, and the keyword is float. But when we need much more accuracy, or 6 digits after decimal point is not sufficient in some cases. In that case, to increase the accuracy, we can go for double. A double uses 64 bits with a precision of 14 bits. And you should remember one thing very clearly. When we consider the different data types, say int, float, double, etc., the size is not specific. Size is not constant throughout. It depends on the machine type and processor. So in 16-bit machines, in size, maybe it is 2 bytes, but it will be 4 bytes when we move to a 64-bit machine. So it will be different. So it's just a comparison. Just you should remember that double means it is doubling the precision. That's it. Then another thing is, say float a is equal to, you are giving a value, and double, it can save the same value. The only thing is that when float type, we can save only up to 6 decimal numbers, but if it is double, you can save up to 12 values. That is the only difference. The precision is doubled by using the data type double. So you can check this. When float is taking 4 bytes, double will take 8 bytes. And in the last class, we discussed about the format specifier, and we discussed that for float, it is %f. In case of double, in some cases, it is LF. In some cases, it is %LD. Okay. And for a 16-bit machine, these are the general size of the main data types. Character, it is 1 byte. Short int, it is 2 bytes. Int, it is 2 bytes. If it is long int, short and long are the specifiers. Okay, short int, for int you have 2 options, that is, it can be short or long. So for example, if we need to address a variable to represent class, so it will vary only from 1 to 10. If that be the case, you need not waste lot of space for that variable. So in that case, you can use short int. But if you need to save maybe an exam register number or a mobile number, say 8 or 9 digits, int is not sufficient. In that case, you give long int. So it takes twice the size. 4 bytes is needed for long int. So you can just learn this. This is applicable only for 16-bit machine. That's why I told the size of data types will vary with variation in machine type. And float takes 4 bytes, double 8 bytes, and long double is 10 bytes. So you can just remember this much. And this is applicable for a 16-bit machine. And to check the size of various data types or size of variables, you have an operator called size of operator. You can directly use it, because when we do coding in a particular processor, you may not be familiar how much size it is required for each variable. So in that case, you can check the size using the operator size of operator. To save some time, I already typed the program. Here I have declared 4 variables: int a, float b, char c, and double d. Okay, and size of integer I need to print, so I gave the printf like this, and percentage d will give the number of bytes, and size of is the operator. You can see that it's in bold, so it is a keyword. Size of a represents size of a variable, which is of type int. So integer, next case float, next case double, and next case character. Okay, hope the program is clear. So let's execute this. This is a 64-bit machine, so you can see that integer size is 4 bytes, float is 4 bytes, double is 8 bytes twice. Okay, 2 into size of float is equal to size of double. Then size of character is 1 byte. So size of operator is used. You can see the size of operator is used to find the size of a data type. Okay. Now the range also, the main, you can just have to check these 3 cases. So if it is a character, then it will be minus 128 to 127 is the range. In case of int or signed int, this is 1 byte. We learned earlier. Character is 1 byte. 1 byte is 8 bits. So minus 128 to 127. When it becomes unsigned, what will happen? There is no bit remaining for sign, because it is completely unsigned. It's throughout positive. So twice the value is possible, 0 to 255. Then same case, signed integer means again minus 32768 to 32767. And when it becomes unsigned, one bit is that is taken for sign. It's called a sign bit, whether it represents whether it is positive or negative. That is not there. Unsigned means it is throughout positive. So 0 to maximum positive value will be doubled. From 32767, unsigned it becomes 0 to 65535. So I have marked these 3 cases. These 3 you need to remember the range. The range for character, signed int, and unsigned int. The rest you can just go through it, no need to learn. Okay. And all these are applicable only for a 16-bit machine, because we saw that int size was 4 bytes in this machine. It's when it becomes 64-bit machine. So here it is, normally for 16-bit machine, we take integer size as 2 bytes and character size as 1 byte. And float as 4 bytes. 32 bits means it is 4 bytes. And double is 8 bytes. Okay. And these are the keywords: character, char. Then signed and unsigned are keywords. Signed means positive or negative is possible. Integer, for integer also signed and unsigned are possible. Then short and long to represent the size. Then double is the keyword. Then extended double precision, that is long double. So all these float double and long double are actually same. Just for increasing the precision, we move from float to double and from double to long double. Okay, so these are the keywords. Then derived data type. So we started with the various data types, that is primary data type, derived data type, and user defined data type. So derived data type means arrays, functions, structures, and pointers. I am not going to the details of any of this, because all these are separate chapters we need to cover. So just learn these names. These are derived data types. And we'll move on to the third one, that is user defined data type. The common two uh, keywords are, one is typedef and the other is enum, which is for enumerated data type. Okay, so first we will check what is typedef. Typedef means typedef type identifier. This is used to give another name for an existing data type. So let's check typedef in detail. It allows the user to define an identifier that would represent an existing data type. This is very important. It cannot create a new data type. That's why we call it user defined data type. User cannot create a new data type. What user is doing is we are renaming it actually. Typedef int units means now even if you use units means it means int itself. Similarly, typedef float marks. So after this, even if I use marks, that is equivalent to float. So instead of giving int batch 1 batch 2, I am giving units batch 1 batch 2. This line is equivalent to int batch 1 batch 2. Okay, so typedef, what it is doing, it is actually allowing us to use another name for the existing data type, and that another name will be more meaningful when we are dealing with a particular program. Okay, so here what is the meaning? Typedef int units means now int, it has the same meaning as units. So instead of writing int batch 1, this is how you declare variable, right? Int batch 1 comma batch 2. Instead of this you can write int. Now you, these both are same after using this typedef int units. Typedef means you are giving units the same meaning as int. So instead of int I am writing units instead of this batch 1 batch 2. Same thing happens with this case. Float and marks become same. Float and marks. Now for the rest of the program, these two are same. So marks name 150. This is how you define an array, which we will learn later. Okay, so this is the use of typedef. Next, enumerator data type. Enumerator, the thing is that you can give a name, say a day of week or color, then that color can have three possible values. Those values we can give within the bracket. Okay, for example, color. Okay, so I am writing enumerator data type. This is a keyword enum. Then identifier, you can give any name. I am giving color and red within curly brackets, red, green, blue. Okay, I'm closing the bracket and putting semicolon. This means that the enumerator data type name is color. And now to define variable, I write enum color C1, C2, C3. So this is how you define variables for enumerator data type. This is how you create or define an enumerator data type. This is how you create variables. Hope you understood it. So this is an identifier name. This is the name of the enumerator data type, and these C1, C2, C3 are the variables. And what is the meaning of this? This means that for the enumerator data type called color, it can have three possible values, say red, green and blue. Whatever value specified inside the curly brackets, these are the possible values which this color can take. Okay, and by default the first value is assigned the value 0, next 1 and next 2. So this means that red equals 0, green equals 1. Without writing anything, when you write this command, red is assigned 0, green is assigned 1 and blue is assigned value 2. Okay, so this much happened with these two statements. It's more clearly explained here. Value 1. This is value 1. Value 1 is assigned value 0, value 2, 1 up to n value. Okay, but there is another possibility. If I want this value R as 10, G as 20, blue as 30, if I want to give specific values, I can give like enum color By default, it will substitute as 0, 1 and 2. So if I need to give value, I should give red equals 10, green equals 20, blue equals 30. If I give like this, what will happen? These particular value will be assigned. If not specified, the default value will be 0, 1, 2 in order. Okay, and I will tell you one more case. That is the third case when I write enum color red equals 10, then only the starting value is specified, then green blue like this. If I end like this, red value is 10, green will be obviously the very next value, it will be 11, and blue value will be 12. Okay, so these are the three cases. Default cases, it is values assigned from 0 to consecutively 0, 1, 2, 3, 4 like that. Second case, for each and every enumeration constant we specify the value. Third case, we specify just the starting value. So the rest of the value will be plus 1 like that, 10, 11, 12. Okay, so this is all about enumerator data type, and the keyword is enum. This is the keyword. And this word, I hope you know this word syntax. Syntax means it is the format by which you have to use various commands or various keywords. For example, to declare a variable, I have to write like data type space variable name semicolon. This is the syntax for defining or declaring a variable. Okay, example is int a or float b. So this is the word of syntax. It is giving the rule or format on how to use various commands in C language. Syntax. Okay. To make the enumerator data type more clear, we will check one program. Here, enum, this is the keyword, and the identifier name given to the enumerator is weekday. Weekday, and the possible values are Monday, Tuesday, Wednesday, Thursday, Friday. You know that by default values will be 0, 1, 2, 3, 4. Okay. And I give weekday, work 1, work 2 as two variables. And now I am printing the value. What I am doing? All these will be integer values. So I am giving within quotes, I am giving 5% D and printing the values of Monday, Tuesday, Wednesday, Thursday, Friday, just to see how they assign the values. So now we will execute it. 0, 1, 2, 3, 4. Okay, by default it will start from 0. Second case which I told was I give values for each. Say Monday equals 10, Tuesday equals 20, Wednesday equals 30, Thursday equals 40, and Friday equals 50. Okay, I assigned values for each enumeration constant, and now let's execute the code. It is 10, 20, 30, 40, 50. So this is the second case. We can directly give value. Next is we give only the starting value. So instead of 0, I give the value as 10. Rest of the values are not specified. So what will happen? Predict the output. Can you predict the output? When you print the values from Monday to Friday, it will be 10, 11, 12, 13, 14. Let's check if it's working. When we compile, we find that it's 10, 11, 12, 13, 14. Okay, so these are the three methods by which we can initialize the value for enumeration constant. Now I define two variables for this enumeration data type. That is, weekday is the name of the enumerator data type. Variables are work1 and work2. So I assign work1 as Monday and work2 as Wednesday. Okay, work 1 and work 2, we are assigning two values. Now I am printing the values. So can you predict the output? Work 1 is percentage %d, work 2 is percentage %d, comma, work 1, comma, work 2. Work 1 is Monday. Here Monday is 10. Wednesday it is 11, 12. So this should print 10 and 12. 10 and 12 for work 1 and work 2 as it is Monday and Wednesday. Let's check if we are getting the output. Okay, it is work 1 is 10, work 2 is 12 for Monday and Wednesday. So I think this is more clear. So we covered the data types. Data types are mainly fundamental data types, then primary or fundamental data types, then derived data types and user defined data types. And in fundamental data types, what all will come? We have integer, float, then character, string, constants, void. Okay, all these will come in fundamental data type. Derived data type, we didn't learn it, just remember the names: arrays, functions, pointers, struct, etc. All these are derived data types. User defined mainly typedef and enumeration data type. Typedef and enum comes in user defined data type. So these are the three basic data types. So in the next class we will learn how to use scanf and we will do some programs related to that. Thank you.